Welcome to the fastest way to learn data structures and algorithms. Today, we are mastering LeetCode 452. Minimum number of arrows to burst balloons. This is a brilliant greedy algorithm problem that pops up frequently in top-tier technical interviews. Let's look at the problem statement. We are given an array of points, where each point represents the start and end coordinates of a balloon on a flat wall. We can shoot arrows vertically from any point on the x-axis. An arrow shot at coordinate x bursts all balloons where the x-coordinate is between their start and end. Our goal? Find the minimum number of arrows needed to pop every single balloon. For our strategy, we use a greedy approach. Think of it like this: to get the most bang for our buck with one arrow, we should wait until the very last possible moment to shoot. That moment is the end of a balloon. If we sort all balloons by their end coordinates, we can shoot an arrow at the end of the first balloon and see how many others it takes out along the way. Let's dive into the dry run. Look at the screen. We have our balloons 1 to 10, 2 to 8, 7 to 12, and 10 to 16. First, we sort them by their end positions. Now they are 2 to 8, 1 to 10, 7 to 12, and 10 to 16. We shoot our first arrow at the end of the first balloon, which is 8. Checking the next balloon, 1 to 10. Since it starts at 1, and 8 is within its range, it bursts. No extra arrow needed. Now for 7 to 12. It starts at 7, which is less than our arrow at 8. Boom! It bursts too. Finally, 10 to 16. It starts at 10, which is greater than our current arrow at 8. We missed it. So, we need a second arrow. We shoot it at the end of this balloon, at 16. Total arrows used? Just 2. Now, let's look at the Python code. First, we check if there are no balloons. If so, we return 0. Then, we sort our points list based on the end coordinate, index 1. This is the greedy choice. We initialize our arrow count to 1, and set our first arrow position to the end of the first balloon. Then, we loop through the rest. If a balloon's start is greater than our current arrow, it means our last arrow couldn't reach it. So, we increment our arrow count, and move our arrow to the end of this new balloon. Think of it like a professional archer at a carnival. You want to wait until the balloons overlap as much as possible, then fire one shot through the overlapping sweet spot. By sorting by the end, you are essentially forcing the most efficient overlap for every shot you take. Looking at the complexity, the time complexity is O of n log n, because of the sorting step. The space complexity? O of n or O of log n, depending on the sorting implementation's stack space. And that is minimum number of arrows to burst balloons, mastered. Save this video for your next interview prep, and follow Leo Academy for more premium DSA guides.